Welcome back, csc121, spring 2020. And I just went over our data types, and we have a data type challenge just to get you to think a little bit. And the way to do this exercise is if you go to your coursework and you look for the hex data type challenge, and you look for this link here. This is actually turning it in the comments. But if you go down to the link down here, you're going to be able to fork kind of a started version in Repl.it that I have for you. So if you click on this, even if it's usually best to be logged in, because then you'll get this fork icon that you could fork it into your account. And that's what I'm going to do right now. I'm going to fork it, and then it becomes part of my account. This is a different account from the home of WCCC. Then what you want to do is go in here, hit this pencil, and just put your name here. I'll just put home of V because I'm recording this as a video, so I'll put a V there. And that's all I have to do. I'll just hit return. And now it's part of my account, and you could work on it. And there's instructions in here. It's just a text file, and it's a little reading here. We went over this in class, but based on the operators that we reviewed in class, we're going to write some lines of code that converts RGB value, which is basically from 0 to 255 of integers, into a hex value that shows 16's place and a 1's place. And we're just going to put those as separate numbers right now. Eventually we'll write a program so we can convert those and have the letters, because in hex values they only use 2 digits, so that if you had 10 16's, they actually use the letter A, and so on. So we'll eventually do that, but right now we'll just make sure that we get the right number of 16's and the right number of 1's and just display them side by side. So those are my instructions here, and it says assign a variable hex. You might actually want to make it hex name, even though it'll work with hex, although I think that could be some sort of keyword. So I'm going to put underscore name when I do that. And then variables of 16's and then 1's. And then we're just going to print them side by side. And we could even put a string next to them to see how it shows up. So I'm going to go here, and this isn't a lot to do. So we're going to start with the hex variable below. And like I said, I'm just going to make it hex name, because if you just do hex, it shows up purple, kind of like it's a keyword, even though it'll still run. I'm going to call it hex name. And I'm just going to put in any value here, like 204 between 0 and 255. And that's my first variable, and it's an integer, 204. And then I'm going to make one called 16's and assign that to an operation. And then I'm going to have 1's and assign that to an operation. What kind of operation would I assign that to? Well, to get the number of 16's in here, remember we did that floor division and modulus. So if we need to know just the number of 16's in here, now we could do 204 divided by 16, but of course we don't want to do that because we already have a variable. So that way we can keep changing the number, but we have the formula the same. So we're going to do hex name here, and we're going to divide that by 16 because that's what we want to find out. And then for the 1's, we actually want the remainder of dividing by 16. Now, we had a thing in class where there were ones that seemed to work when you used the 16's variable, but it was just a random lucky kind of thing that happened because they were actually the same remainders, although the number would change. So make sure that you use 16 here and not the 16's variable. So what we're going to do here is do the same thing, is we're going to take the same value and the same variable, hex name, which is still going to be 204, and we're going to use the modulus, and we're going to use 16. And that'll give us the remainder after we divide by that. And what was happening in class, if you use 16's in here, it was actually getting like a 14, and it was dividing by 14, and it just happened that the remainder was the same as if you divided it by 16. And it seemed like it was working with that, but you should put 16 here. So if we run this, nothing's going to happen because we didn't print anything out yet. So let's print something out. I can even put a little pound sign here and put output for our comment and just indicate that it's our output. You don't have to do that. And then we'll do a print function. And in the parentheses, I'm just going to put the variables, and I could separate them with a comma. So I'm going to do 16's, comma, and then 1's. And it should print out the 16's and the 1's. And it should print out the number of 16's in 204, and then the number of 1's left over in 204. So it comes up with basically a hex number. So let's try something easy first. Let's try the number 3. So there should be 0 16's, and there should be 3 1's. Let's see if that works first. And what we're getting here is a float, and we shouldn't be getting a float. And what did I do wrong here? This should be floor division. I didn't do floor division. All right, let's fix that and run this again. And there we go. 0 and 3. So there's 0 16's and there's 3 1's. And usually they're together in hex. So it would actually look like that. You would still have a 03 in hex. And I could even go in here and I could even add things to it if I want to. I could put a little string in here. So I could even just do it with a comma. I could do 16s in a string and I could put a comma. And then over here I could put ones. And because I'm putting in a string, I could put a number in here. So I'll just put ones and I'll put a colon and a space and then finish that off. And I'll put a colon and a space here and I'll run it like this. See what that looks like. And I have an error because I didn't put a comma here. And that's a syntax error because I didn't do that correctly. And it even says syntax error. So it didn't do anything yet. So let's run it again. And there we go. 16s, 0, 1s, 3. Now, I don't even like the way that looks. I'm going to take that out. It's too hard to read like that. I'd rather just read it like this with the two numbers because that's how you would see hex. And let me get rid of the extra comma there. So I'm going to put that back, but that's how you could do that. But with the way the spaces are in there, it's even harder to read. So I'll run this again. And let's try this out. Let's try a bigger number. Let's see, 16 times 4 is 64. So let's try 64 because that should be 4 and 0. That's what we should get for that. So let's see. And that's right. And let's try our 204. And we're getting 12 and 12. Now in hex, that would actually be a C and a C because we actually don't have, you can't have two digits with hex. Or once you get to 10, there's an A, and then 11 is a B, and then 12 is a C. So this would actually be CC. So that actually works like that. And that's all we had to do. It was just using the floor division, using modulus. And it was just kind of, we were just using the floor division and modulus and just kind of solving a problem here. Eventually, we're going to use some conditional statements, some if statements, and then we're going to probably make a function and then be able to output our CCs and things like that when we do that. Instead of having 12, 12, we could have CC when we do that. So that was our little data challenge.